to Should Observe classes. Here I am solving the IIT JAM 2019 physics paper. So this paper is not so hard, but some questions must be tricky. Here the third question in this paper is, in the thermal neutron induced fission of 235 uranium, the distribution of relative number of the observed fission fragments versus mass number A is given by for which curves. Okay, so here the main funda is the neutron induced fission. So what is neutron induced fission? In nuclear physics, nuclear fission is a nuclear reaction or a radioactive decay process in which nucleus of an atom splits into smaller or lighter nuclei. Nuclear fission is a process in which nucleus splits into some lighter nuclei, some smaller and lighter nuclei. Okay, so nuclear fission is the process. This is the process in which nucleus splits into some smaller or lighter nuclei. Okay, the fission process also produces the gamma rays, neutrons. This process also produces gamma rays, neutrons. Okay, so and release a very large amount of energy, Okay, by nuclear fission this produces gamma rays, neutrons, large number of neutrons, release a very large amount of energy. Okay, so here I see you a example of neutron induced fission. So what is the example? It is the problem here. So here I see an example. Here this is the 235 uranium nucleus. Okay, the neutron, one single neutron is absorbed, is neutron is absorbed by this uranium 235 nucleus, it turning into a excited uranium nucleus of 236. This is the excited uranium atom. Okay, this is an excited uranium nucleus or atom. Okay, so this with the excitation energy provided by the kinetic energy of the neutron, this provided by this kinetic energy of neutron plus the forces that bind the neutron plus the forces bind the neutron. Okay, then this by this kinetic energy of neutron and the forces bind the neutron, this 236 uranium splits into two smaller elements. This is 92 krypton and 141 barium. This is the smaller elements, two elements. Okay, so here this process is induced nuclear fission. So now here the question is thermal nuclear induced fission of 235 uranium, the distribution of relative number of the observed fission fragments. Relative number of the observed fission. Okay, so for TC 99, this is the mass number. TC is tantium and CS is cesium. Here the mass number is 135 of cesium. This is nearly about relative mass number. This is about nearly relative mass number. So when we plot these two, in the y-axis this is yield and in x-axis this is mass number. Okay, here the percentage of yield is for TC is 6.13%. Okay, and yield is for CS is 6.9%. This is about nearly equal. These two are nearly equal percentage of yield, so here this yield for tantium and cesium is nearly equal and also maximum in all of the fragments. This is also maximum in all the fragments. So here the curve is in the mass number, this is 80, this is 120. So the tantium is near about between 80 and 120 is 99 and this is 160. So in between this the cesium is near about 135. Okay, so here the curve is, this is for tantium and this is for cesium. Here the curve is just like that. Okay, this is for tantium and this is for cesium. So this curve is exactly matching with the option A in the question. So in this question, option A is the correct option. So this is for the number 3. So that's all for today.